We're talking scales today, not the ones that you step on to find weight, not the ones that are found on lizards. Scale is another way of looking at a ratio, a conversion per se. So we're going to look at this first one together, our first scale problem. Here we go. You'll get a better sense of it in this one. Given a scale factor of 1 to 557, so this means that 1 inch on this map is equal to 557 miles on a map of the US. If the distance from Seattle, Washington to San Jose, California is 1.5 inches on the map, define a proportion to find the actual distance between them. So that's what the scale is. A scale is just something that's literally written on a map that tells you how to convert it to the actual size. So if you see 1 inch on this map, it is equal to 557 miles. And so here's our problem. We want to know what is the real distance between Seattle and San Jose on the map, and we're going to define that proportion. You're going to see the rate. We know our facts. We know what the scale factor is, and we know that on the map it is 1.5 inches. And here's our plan. It's the same one we've been using this whole time. Use math. We're going to use the scale factor for the first ratio. And we're going to cross multiply to figure out the conversion. And then we're going to just use our algebra skills to calculate the unknown in the situation. Now these numbers, notice they are not friendly. I have 557 and I have a 1 and 5/10. So we are going to be using a calculator for this one so that we can do this more quickly in the model as opposed to doing all of it by hand. Okay, math marbles, let's jot this down and we'll jump into our first example. Okay, so I've already given myself a little bit more room because, again, my numbers aren't friendly, so I want to use the calculator, and to give us more space on the page, I'm kind of just opened and widened it up a little bit. I'm going to start with our scale of 1 inch is 557 miles, and we have 1 and 5/10 inches on the map. So this is a situation and we're trying to figure out how many actual miles that is. So we're going to do our cross multiplying, and in the first part, we know we're going to have 557 times 1 and 5/10. On the other end, we just have 1 times a number. So I'm going to start by writing this out. 557 times 1 and 5/10 is equal to 1 times a number. And so let's figure it out. I'm going to write this down on my calculator. 557 times 1 and 5/10. And I get 835 and 5/10 is equal to 1 times a number. And now I just turned this into a division sentence. I may not really need to, but I'll do it just for the sake of consistency. I think some of you are getting it in your heads. 835 divided by 1 gives us that number, which would be 835 and 5/10. And what unit are we talking about? Miles. So let's put this down. The answer, the actual distance, between Seattle and San Jose is 835 and 5/10 miles. All right, so there you go. Obviously, if you don't have a calculator, this would have taken us a lot longer, but because our numbers weren't very friendly, I had us use a calculator and it saved us some time. So hit pause and let's jot this down into your notes. And let's look at our second example. A local park is in the shape of a square. A map of the local park is made with a scale of 1 inch to 200 feet. Here are the two parts for this one. This one's a little tricky to understand. If the park is shown as a square on the map, each side of which is 1 foot long, how long of each side of the square part? Okay, so on the map is a foot long. This is a pretty big map then. And so we'll figure it out in real life what that is. And second part. If a straight path in the park is 900 feet long, how long would the path be when represented on that map? They're asking us two things. One, what is the length of the side of park if it is 1 foot on the map? how long is 900 feet on the map? So there's two parts here, a part A and a part B. And we know the scale, 1 inch is 200 feet. And we know on the map, one side is 1 foot or 12 inches. So what is that in feet? And we know that the path is actually 900 feet. And so here's our plan. We're going to use math to organize both situations because then we have an A and a B. We're going to use the scale factor as the first ratio. We're going to cross multiply. And we're going to use algebra to calculate the unknowns. So that is our goal for today, Math Marbles. So let's jot this down into our notes and we'll do our second example for today. So I'm going to be very transparent, Math Marble. When I was reading this problem, at first it was really tricky for me because of the unit. So I'm going to just express that as we're going through this one. And it even came out as I was writing the scale in the first one. Like we know our scale is 1 inch to 200 feet. And at first I was writing inches of feet. But then as soon as I got to that first part of problem in A and it said one side of the map is 1 foot, I was like, oh, I can see why kids will put the 1 over here on the 1 foot instead of, because of 1, that's the unit I was given, instead of putting a 1 here. But even that doesn't work because we don't have 1 foot. We would have, this has to be given in inches. So I wanted to go a little further and to help differentiate here on our scale, I'm going to differentiate the map, which gives it in inches, and the actual, which is in feet. And that helps us because we know in the first problem, we're on the map. The square is on the map. So on the map is 1 foot, 1 foot, which is the same as 12 inches. So I'm making that distinction very clear that my map, one side of the park is a foot long or 12 inches. I want to have that there. And we want to know how long the side of the park actually is. So it's not the greatest written problem, but it is great for just uncovering this misunderstanding. Now we can cross multiply. And when we do 200 times 12, we get 2,400 and we have 1 times the number. So let's express this. 1 times the number is 2,400. We know the only number that can be and has to be 2,400. So let's 2,400 what? Feet. So let's express this in our sentence. The side of the park is 2,400 feet long. I kind of want to put the actual side. So let's add that word, the actual side of the park, so that we don't get it confused and think it's just a really huge map. So let's go to the same one in part B, and this one's a little easier. So again, we have our map, and our unit is in inches, and we have the actual, which is in feet, real life. We have our scale, 1 to 200, and we know if a path in real life, the path in the park, it is 900 feet. So what is it on the map? That's what we need to figure out for B. So we'll do the same thing. We're going to cross multiply. We get 200 times the number and 900. So let's write that sentence down. 900 is equal to 200 times the number. Change it to division. 900 divided by 200 gives us that number. Now that, to save time, I'm not going to do that long division. We're going to use our calculator. 900 divided by 200 is equal to 4 5/10. Make sure that decimal shows inches. So let's put that into our answer. The path is 4 5/10 inches long on the map. And there you go. So you can see how, again, I'm using math, and I want to be super, super clear when writing my units on the side, and also making sure I understood where they were from. Because even though I can have something that's a foot long on the map, I know the map has a scale in inches, so I want to keep it consistent in inches. So that's our lesson for today of Math Marbles. Jot this down in your notes, and let's get to our practice. I will see you in the next lesson. Take care.